Hello folks, welcome back to Merrill Math. My name is Mr. Merrill, and today we are looking at solving and graphing compound inequalities. So your first question might be, well, what is a compound inequality? We can think of these as inequalities that are combined together. There are two or more inequalities. And we could think of these as an and or an or, and that will become a little bit clearer when we start to graph them. So we have an example here. So 3 is less than x is less than 10. We're going to think of this as saying two separate things. So for the first one, 3 is less than x. And for the second one, x is less than 10. So for the first part, what we'll want to do, actually, let's just work through this one. So for the first bit, what we want to do is flip it over, because we tend to think of, when we're graphing these, we tend to think of the variable as being on the left-hand side. Now, you don't have to, it's not necessary, but it is easier to think about when we treat everything kind of equally. So if we think of flipping this around with an equation, you just flip it over, right? In the equal sign, it doesn't matter. But when we flip this, the sign has to flip with it. So as we notice, the larger opening is pointing toward the x. The larger opening is pointing toward the x. So we want to maintain that orientation. Okay, so this statement up here, 3 is less than x is less than 10, is saying two things. X is greater than 3, and it's also saying x is less than 10. So if we wanted to graph that, we need some information here. We need to know where 0 is. We've got 3 and we've got 10. So when we go to graph this, we need to first look at whether or not we're going to include the point. So there's no line underneath any of these. So neither of the points get included. So those are both open. And x is greater than 3, so we're looking at stuff to the right of this, but this is limiting us. It's also less than 10, so it's this. So if we were thinking about this statement, this would be an and. So x is greater than 3, and it's also less than 10. Okay, let's look at some more examples. Here, let's look at example 1 here. I guess it's technically example 2, but we'll call the first one example 0. Ooh, sorry, I'm kicking the mic here. All right, so 0 is less than x is less than 3. So this is saying two things. 0 is less than x, and it's also saying x is less than 3. We're going to do the same thing here. We have to flip this over. So that gives us x greater than 0, and this gives us x is less than 3. We can go straight to graphing from this because we don't have anything to solve. We need to know where 0 is. We need to know where 3 is. Now we're looking at stuff that's greater than 0, not equal to, and less than 3, not equal to, so those are both open. We're looking at stuff to the right of this and to the left of 3, and that's our graph. So that one is solved. Okay, let's look at this one here. Example 2, we've got 2 is less than or equal to x plus 3 is less than or equal to 5. Now, you don't have to split these up into two separate statements. You could actually just graph this as it is, because there's nothing to do here. This one, we're going to do, I don't want to say the advanced method, but we're going to do sort of a more advanced method. We're going to treat this as one statement, and we're going to do everything all together. So we're going to treat this, how do I want to say it? So we're going to look at all of this as one cohesive piece. So we're going to do everything all together. Does that make sense? It makes sense in my head. So let's just dig into this. So we're going to subtract 3, but we have to subtract 3 from all sides of this. So we do the same thing on every side of the inequality symbols. So 2 minus 3, that gives us a negative 1. X plus 3 minus 3, that leaves us with x. And 5 minus 3, that leaves us with 2. So we have 1 is less than or equal to x is less than or equal to 2. So now if we want to graph this, we have, here's 0, here's 2, here's negative 1. We have lines underneath here on both of them, so we're going to include this point, so that gets filled in. We're going to include this point. Now, x, if we read this backwards, it says x is greater than or equal to negative 1, so that's shading to the right. And this is less than 2, so we're shading to the left of this. And that's our graph. Take a look at a couple more examples so we can kind of get the hang of these. So I talked about 2 different types of problems, ands and ors. So this next example is an or. So sometimes you'll get problems like these where you have 2 literal separate statements joined by an or. So you treat them exactly the same as you would any other inequality, but we're just going to be solving them separately. So here we're going to subtract 2. We're going to subtract 2. So we've got negative x less than or equal to a negative 3. I'm going to jump over here and add 2. So I've got negative x is greater than or equal to positive 3. Now, both of these have a negative 1 that we need to divide by. So whenever you divide by a negative 1, this sign has to flip. So this is going to be a greater than, and this is going to be a less than. So if we divide by a negative 1, that leaves us with x. That leaves us with negative 3. This one leaves us with x, and that leaves us with positive 3. So we have x is greater than 3, greater than or equal to 3, and x is less than or equal to negative 3. This is an or statement. So let's look at graphing that. So if we put this on a graph, here's 0, here's 3, here's negative 3. So they both have lines underneath, so we're going to include both of the points. We're looking at greater than or equal to positive 3. So that's going to be over here. And less than or equal to negative 3. So that's going to include this point and go to the left. So we can see the difference between ands and ors. In an and statement, something like this one, it was shading the area in between. In an or statement, the 2 areas, I hit the camera with that, the 2 areas are not connected to each other. So we have this or that. So we'll look at another one of those and then wrap things up here. So example 4, we've got x minus 3 less than negative 4, or x minus 1 is greater than 5. So we're going to add 3. Over here we're going to add 1. So that gives us x less than negative 4 plus 3, that's negative 1. Here we've got x is greater than 6. So if we go to graph this, we've got 0, we've got negative 1, we've got 6. There's no equals underneath any of these. There's no lines. So we're not going to include this point. We're not going to include that point. We're looking at stuff that's less than negative 1, so that's to the left. And we're looking at greater than 6, and that's to the right. So we have 2 separate areas. Okay, let's see if I can wrap this up better than I did in my last video. If you have any questions or comments, points of clarification, be sure to leave those in the comments below. If this video helped you out, be sure to like it. If you want to see more, please subscribe. Otherwise, thanks for watching.